Let's take a look at this example. We're supposed to find first the current IS. IS is the current which will go through the resistor RS. Okay, so the current which goes through the Zener diode is given. So I know that 5 milliamps is going through the Zener diode, and simply you're supposed to realize that the diode is working. So now we can write the formula for the current IRS, okay, or other words IS. IS is equal voltage source minus the voltage across the Zener diode divided by the resistance of resistor RS. So I have VS minus VZ over RS, which is equal VS 18 volts minus 6 volts divided by RS 240 ohms. This is equal 18 minus 6 divided by 240. This is equal 50 milliamps. Okay, so this is my current which will go through resistor RS. Next, so this is my IS, other words. Next, I'm supposed to find the current which will go through the resistor RL. So I can write that IL is equal IS minus IZ. Okay, if you are going to use KCL, you're supposed to realize that my IS current is going to split into two currents. Okay, this is my IZ and this is my IL. Okay, so in order to find IL, I'm going to subtract from IS IZ. So I have 50 milliamps minus 5 milliamps, and this is equal 45 milliamps. Okay, so this is the current which will go through the resistor RL. And let me remind you, if you want to measure the current which goes through the resistor, you're supposed to always open the circuit and connect the ammeter in series with this resistor. Okay, this is just extra information for you because probably you are going to test this circuit in the lab. So just in your future reference, I'm just giving you this information. Next, we're supposed to find the voltage across RL. Okay, VRL is equal to VZ. Okay, because resistor is in parallel with the diode and the diode is working right now, so the voltage across the resistor is equal to the voltage across the diode. So I can say this is equal 6 volts. So if you want to find resistor RL, RL is equal VRL over IL. VRL is equal 6 volts over 45 milliamps. This is equal 6 divided by 45 exponent 3 negative. This is equal 133.33 ohms. Okay, so this is the resistance of my resistor RL. Next, I'm supposed to find the power at the Zener diode. Power PZ is equal IZ times VZ. Okay, the current which goes through the diode times the voltage across the diode. So I have IZ is equal 5 milliamps times VZ, which is equal 6 volts. This is equal 30 milliwatts. Okay, so now we can say that the problem is solved.